Alright, you guys, so we're still using coordinates to prove geometric theorems. We've done triangles. This is slide 11 on a quadrilateral. So I'm going to open my GeoGebra and see if I get a blank or if I get a quad. I'm going to get a blank. Okay. Alright, so it looks like I'm going to have to plot some points. Yes, I am. Alright, A is 10, 10. And again, these are big numbers, so I'm not going to try and hunt them down. It's just easier to put them in the input. 10, 10. Oop. Helps to type them correctly. Make sure you hit enter in between, you guys, because you want that little A to pop up. All right, second one is 22, 2. 22, comma 2. Hit enter. I'm probably going to move this out so I can see it. Yep. Okay. All right, so let's see. Next is 38. So in parentheses, 30, comma 8. Hit enter. That's going to be way out there. All right. And the last one is 12, 20. In parentheses, 12, 20. Hit enter. All right, where's 12, 20? All right, there it is. Oh, kind of looks like a trapezoid. I'm not really sure if that's what that is, though. Not yet. All right, so I'm going to connect them to form a quadrilateral. So come over here to your segments.
On this interruption, we need the following students to report to room 308 at this time. Freeman Moore, Memory Shimmerhorn, Candace Ballard. These students bring your belongings and go to room 308 at this time. Thank you.
All right, so pardon the interruption. I'm putting in my sides right now. They asked me to find the slopes. So when you're looking at something being a trapezoid is a quad that has two sides that are parallel. I have a feeling they're doing my slopes because if two of them come out to be the same, namely DC and AB, if those two come out to be the same slope, then this is definitely a trapezoid. So we need to come up here to find slope. I'm going to find the slope of each one. So I'm just clicking on them. Oh, yeah, look at this. AB has a slope of negative 0.67. CD has a slope of the same, negative 0.67. These are for sure parallel lines, and that means you have one set of parallel lines. This is a trapezoid, y'all. All right, so let me get all my information in. So A to B is a negative 0.67. BC looks like it's a 0.75. I'm looking right there, 0.75. I already said CD is a negative 0.67. Looks like DA was a 5. Remember that thing? Wow, man, undo that. Yeah, slope for 80 is a 5. All right, note them in the table. Got it. Take a screenshot of the quad with its slopes label, paste it below. Not going to do that. Based on the slopes, what type of quadrilateral this is a trapezoid. Because I have one set of parallel sides. One set of parallel sides. If I had two sets of parallel sides, it'd be some sort of parallelogram, rectangle, rhombus, square, something like that. Question 3. All right, revisit your work in question 2. Is the trapezoid that you created an isosceles trapezoid? How can you tell? Okay, well, an isosceles trapezoid is when your two legs are the same distance. Now, I see that none of these are the same over here, so this is not an isosceles trapezoid. For that to be isosceles, AD and BC would have to be equal in length. So these would have to either be both 10s or both 10.2s. This is a 10, this is a 10.2. They're not the same number. This is not an isosceles trapezoid. No. This is not isosceles. How can you tell? Oh, okay, so because the legs are different in length. All right, so if I didn't have GeoGebra, I would just do the distance formula. And again, it would prove that these are not the same length. So distance formula would prove these are not equal in length. Now remember, ACT, they like to use the word length, they like to use the word measure, they like to use the word distance. They all mean the same thing. All right. Oh, self-evaluation. Boom. All right, sweet. All right, so this is not an isosceles trapezoid. It was a trapezoid because two of the sides had the same slope.